Today, I'm going to show you switching loss analysis on silicon carbide using this silicon carbide evaluation board. Switching loss is just one of the measurements available with the 5-PWR Power Supply Measurement and Analysis package. Switching loss measurements work by multiplying the voltage and current across and through a FET. Since two separate probes we'll use to measure those factors, it is absolutely critical to accurately time-align the measurements. The upgraded 100 MHz AFG in the 5 Series B comes in handy. I'll configure the AFG output for a max amplitude pulse. I'm using this Tektronix fixture and the 5 Series built-in AFG to D-skew. Connect the voltage probes to 1/2. Now, you can D-skew based on the rising edge. If you want to increase D-skew accuracy, add a delay measurement. Turn on statistics and collect a few hundred pulses. The resulting average will give a more reliable delay value than a single measurement. Now that the probes are D-skewed and warmed up, turn off the AFG and run a quick auto zero. This will remove any imbalance that will affect switching loss measurements. Okay, now we're ready to connect to the SiC half-bridge board. This half-bridge board can be used for double pulse test, synchronous buck or boost, or asynchronous buck and boost. I'm using the asynchronous buck configuration, and I'm going to keep the operating voltages modest since I don't have a high power safety equipment set up here. One cool thing about this Wolfspeed board is it uses a current viewing resistor to measure drain current. The CVR is a specialized shunt resistor, placed in series with the current flow, and allows us to use a high bandwidth voltage probe to measure current via Ohm's law. I like to use a TPP0502 for this ground reference CVR, and a TMDP0200 to measure VDS across the upper FET. A couple of DC power supplies provide the rail voltages, and to stimulate the onboard gate driver, I am again going to use the 5 Series convenient built-in AFG. After checking my connections, I'll energize the circuit. Trigger on the VDS channel. Set up custom units for the 10.2 milliohm CVR. And now, add the power measurement. Double tap the new badge in the sidebar and put the transistor's RDS on from the datasheet in the Configure tab. If you want more statistics, increase the record length to include multiple cycles and add a results table. The results table will show statistics based on all of the pulses that are in the current record. This circuit looks to be losing just under 200 milliwatts during conduction. To get more information about how the circuit is operating, add more probes. An IsoView probe is a perfect fit for high-side VGS and is incredibly useful for tuning the gate driver parameters like the dampening resistor size or the effects of negative gate drive voltage. Our TPP0850 1000 volt passive probe is also commonly used for VDS measurements. But be careful not to use it on any floating measurements. For a floating measurement, use a differential probe like a THDP0200 or a TMDP0200. This half-bridge circuit is the building block for dozens of different power conversion applications, from 3.3 kilovolt locomotive boost converters to compact solar cell inverters. Tektronix power analysis software and probes can help you understand and optimize your designs and power our electrified future.